This time on Wonders of Space, it's the planet Jupiter, the king of the planets, the first gas giant we find, and the fifth planet from the Sun. Orbiting at an average distance of 778 million kilometres, it takes Jupiter almost 12 years to go once around the Sun. And Jupiter is big. The pictures we're seeing don't really do justice to just how big this planet is. It's 140,000 kilometres in diameter. But what does that mean? That red spot you can see on the picture, that is a colossal storm. That is 3 times bigger than the Earth. Jupiter's so big, in fact, that when you take the other 7 planets and put them together, it is 2.5 times bigger than their combined size. It is truly huge, as I'm not sure what more I can say. A little interesting thing that I found out, if Jupiter was a mere 80 times larger than it is, I know that is a huge number, but on astronomical terms it's not really, it would actually be large enough and massive enough to initiate fusion at its core. It would be a star, a very small star, but a star nonetheless. What that could mean is that Jupiter is the failed binary twin of our star, the Sun. When we look up at the night sky, we find that actually the majority of stars up there are in fact binary pairs. You have one larger star and a smaller star orbiting it. Jupiter could be that smaller star, but obviously it never quite made it to being a star. Because of its immense size, it has an immense amount of moons, of course. 79 at the last count in 2018. That's because of its huge gravity. And that same gravity has played a very important role in protecting life here on Earth. In the 1990s, the comet Schumacher-Levy 9 was seen to collide with Jupiter. There's some pictures on screen now. You can see the impact scarring the cloud layers of Jupiter. And we believe that all through history, Jupiter has played a similar role, intercepting objects from the distant outer solar system on their way in and either casting them out into interstellar space or absorbing them into itself to prevent further collisions further in. Obviously it's not deliberately doing that, it just happens to be because it's so big. What about the name though, Jupiter? Well, in Roman mythology, Jupiter is the king of the gods, equivalent to the Greek god Zeus, but we use the Roman ones. We use the Roman god names for all of our planets, which is interesting really, as I think in popular consciousness the Greek gods are probably better well known. But the Romans were the major civilization after the Greeks. In the Renaissance period, European science was at a pinnacle. It was flourishing. And so when the planets were getting their names, Latin was the dominant language. Latin obviously coming from use in Rome. We're using the Roman god names. Now there have been a number of other scientific epochs, scientific peaks in the Middle East, in China, but as the majority of Western civilization is based on that European colonial period, we use the Roman names. It's as simple as that, really. Now, Jupiter has been observed by humans for centuries. As with the inner planets, we can see it with the naked eye in the night sky. In real terms, it's the third brightest object in the night sky, behind only the Moon and Venus. In terms of telescopic observations, we've been looking at Jupiter for about 400 years. It was Galileo who first pointed a telescope at Jupiter and saw stripes, bands of colour going across it. He also saw some mysterious objects that were around Jupiter. These would later be known as the Galilean satellites in the Jovian system. And what he observed was that they appeared and disappeared at different times. They appeared on different sides of Jupiter. They came and went. And this, over a period of months of observations, allowed him to figure out that the moons were orbiting around Jupiter. And this was the first thing, other than our moon of course, that we had seen to orbit something else. We believed at various points that everything went around the Earth and then everything went around the Sun. So here we are seeing something going around Jupiter as well. It was an important discovery. Now, That storm that we mentioned earlier, the Great Red Storm, that Great Red Spot that is 3 times bigger than the Earth, was observed by Galileo over 400 years ago. It's still raging on and shows no sign of abating. That may be partially because Jupiter has no solid surface. On Earth, weather patterns come and go because of the interaction between air masses and the oceans and the land surfaces. On Jupiter, there is no land surface for the storm to dissipate over, so it can keep drawing energy from deep within Jupiter and keep raging on. Who knows how long it will carry on for? Maybe for the entire life of the planet, or maybe it will split up and another storm will form. Who really knows? Who can say at this stage? So far, there have been 9 missions that have visited Jupiter. It's a little bit strange actually, as the king of the planets, Jupiter hasn't been really studied up close more often. The majority of those missions, 7 out of the 9 in fact, have only been flyby missions. The probes were sent, and by the time they reached Jupiter, they were travelling too fast to be able to slow down and enter orbit. And, well, they showed us some spectacular pictures of the planet, some of which are up on screen and have been up on screen for some time now. And some of them were just using Jupiter as a flyby destination to gain speed on their way elsewhere. Of particular note in that regard are the Voyager 1 and 2 probes that were sent out in the 1980s, and the 1970s, into the 1980s and the 1990s even. They were still active. They're still active today, in fact. What am I saying? And they flew by Jupiter in order to gain something called a gravity assist on their way to Saturn and Neptune and Uranus in the other order. It's Uranus, Neptune, not Neptune, Uranus, but never mind, stick with me. In terms of probes actually deliberately sent to orbit Jupiter, we've got the first, which was Galileo, named after the astronomer who observed it, and it orbited from the mid-1990s until the mid-2000s. It also carried an atmospheric orbiter which was dropped into the atmosphere of Jupiter to study what it was made of. So the majority of what you're seeing is hydrogen. Like I said, Jupiter may be a failed star, and it would make sense therefore that the fuel of a star, mainly hydrogen, would be present in large quantities. There's also mixtures of lots of other gases. That's why we see the colours in the stripes that we do. Some of the pictures may be slightly exaggerated to show off those colours, but that's how science works. We need to enhance colours to see them better. With the naked eye, it would be a lot duller, but still quite the sight if you were lucky enough to get close to it. Speaking of getting close, there is a problem with Jupiter. It has an enormous magnetic field which traps a huge amount of radiation. Humans would need feet or meters even of radiation shielding to get close to Jupiter, and the same goes for probes. This may be one reason why it's not been explored very much. It's very difficult to operate near Jupiter. Now, however, the Juno space probe is exploring Jupiter. Juno was actually named for a Roman goddess who could see through clouds. So Juno entered into quite a large elliptical orbit, so it's not a full circular orbit, and it did have an engine problem which meant that it didn't decelerate into the circular orbit it was intended to. However, scientists, being the clever people that they are, managed to find out a way of doing the science they wanted from the compromised orbit that Juno is in, and it is still returning data. It is finding out new things, it's taking pictures of the storms on Jupiter, learning about the atmosphere, and will continue to do so hopefully for many years to come. A quick note on Galileo, I didn't say what happened to it. After about 2005, I think it was decided to crash Galileo, to command it to burn its engines and crash into Jupiter. This was done to safeguard those 4 main moons that Galileo discovered. They are Io, Europa, Ganymede and Callisto. Now, we believe we've found evidence of liquid water on at least Europa and possibly on Ganymede as well, but we're not sure. So, rather than contaminate it with a stray probe from Earth crashing into it, we tried to keep the environment as pristine as possible, and Jupiter is a pretty good way of doing that. Like I said with the comet earlier, crash your satellite into it, it's not going to contaminate any of those moons, so we can study them in a pristine state later on. Okay, the video might be getting a little bit long now, so I'm going to wrap it up. That's about all for Jupiter. If you're interested in the Galilean moons, Io, Europa, Ganymede and Callisto, let me know in the comments and I'll think about doing a video about those separately. If there's anything you think I've missed, anything you know about Jupiter that I could have added into the video but didn't, again, share it down below. If you liked the video, please do consider giving it a like. And if you want to see more of this type of content, looking at the planets, then later the moons, the comets, the asteroids and other things in the solar system, why not subscribe to the channel? As always, thanks for watching and see you in the next one.